In this goal, we are going to be looking at bond length. Bond length is defined as the distance between the center of one atom to the center of the other. And if you remind, in this goal, we are going to be looking at bond length. Bond length is measured as the distance from the center of one atom to the center of the other atom. So if you draw a little picture of this, you see that you can take the radius of the first atom and the radius of the second atom and add them together, and that will be your bond length. The radius is not a constant. It actually depends on if it's ionically or covalently bonded. Typically, if we have a bond that's covalent, the bond tends to be shorter, the atoms tend to be closer together. And if we take one of those atoms in that covalent bond and then ionically bond it, we find that the bond ends up being a little bit longer. So these bond radii are measurements that are an average of a lot of bond lengths that have been measured. And all you really do on these problems is you take and look up each radius, and you should only have two to ever look up because a bond is just between two atoms, and you just add their radii together. So I like to draw a picture to show this bond length. So we have two atoms here, and our first atom is hydrogen, 37 picometers, and then we have our second one is 77 picometers, and all I need to do is add that together. So we have 7 plus 7 is 14, carry the 1. We have 8, 9, 10, 11. We have 114 picometers as that bond length. So again, that bond length is adding one radius to the next. Let's do the next example here. So we have nitrogen is 70, and we have sulfur is 103. And I would add those up for the bond length, and that would be 173 picometers. So using the chart in your packet, we can figure out these bond lengths. So you're not expected to memorize this chart of radii. It will be given to you on the test and of course right there in your homework. So let's do this first one. Find the bond length of aluminum and iodine in aluminum iodide. So let me draw my picture. And we have for aluminum, looking up, it is 118 picometers, and then iodine is 133. So adding this up, we get 251 picometers, if I did that correctly. And that is just the length of one bond. The molecule itself has aluminum with 3 iodines around it, and we are just expected to find the length of one bond, not all 3. So don't go crazy and start multiplying things by 3. So it's always just adding up the 2 radii. The radius of one plus the radius of the second one, that is equal to the bond length. Let's do the next one. So this is the bond length of oxygen and hydrogen in water. And I'm not drawing my circles according to their size, but for oxygen it is 73.5, and for hydrogen it is 37. So adding that up, we get 110.5, if I did that correctly. Okay, just adding those two numbers together. Let's look at the next one. So this one's a little bit different. We're not given what the element is. We're just told that it is X2. So we have two X's that are bonded together, and their bond length is 240. And because it is the same element, I can just take that number and divide it in half, and I know that I'll have 120 plus 120. And that's what it wants. It wants the radius of X, and I will say that X is 120 picometers. Let's do our last one. So we have Y2. So again, there are two Y's, and it says the bond length is 180. So if I cut that in half, I get 90 plus 90. That equals 180. And the problem is saying, what is the radius of A if AY is 150? So we have 150 for this bond, And we know that one is A and one is Y. And we do know what Y is. Y is 90. We just found that out. So to find that missing radius, we take 150 minus 90 and we will get 60. So 60 is our bond length, 60 picometers. So this last one, this is about the hardest thing that I can throw at you as far as bond lengths go.